Morning students. In previous class we have learned stoichiometry and stoichiometric calculations for chemical reactions, and very important, how to calculate how to determine the limiting reagent in a chemical reaction. So limiting reagent is very important. Next, today we will discuss about redox reactions. First, we will see the definition of redox reaction. The reactions in which both oxidation and reduction takes place simultaneously is called redox reactions. So, in our daily life is also redox reactions takes place. As well as the oxidation, some reactions are oxidations, some reactions are reductions. Best example for the oxidation is a rusting of iron. Rusting of iron is a oxidation reactions. So now, first of all, we will define what is the oxidation and what is the reduction. So first, what is the oxidation reaction? One is oxidation, one is reduction. So oxidation reaction means addition of oxygen. Directly I will write the small. So addition of oxygen or addition of electronegative element. Addition of electronegative elements, that is nothing but non-metal. If we add the non-metal to a substances, that is oxidation reaction. Next, another statement is also there. If loss of electrons from the substance is called oxidation, that substance undergo oxidation. Or if sometimes oxidation state is also increases, we called as that element undergo oxidation. So depending upon the four terms. So first one is addition of oxygen or addition of electronegative to an element is called oxidation. And the third one is loss of electron. Loss of electrons is called oxidation. And the fourth one is if oxidation state increase in a substance, that substance which undergo oxidation we called as a oxidation reaction. So IST is opposite for the redox reactions. And the very important, another one, if a removal of hydrogen or removal of electropositive element which is metal. So it is also one of the parameter to detect the oxidation. Which are the parameters? First one is addition of oxygen or addition of electronegative element, that is non-metal. If loss of electron is called oxidation or oxidation state increases. Next, removal of, so this symbol is not minus or plus, just plus means addition, minus means removal. So our convenient we sign the plus or minus, okay. And the removal of hydrogen or a removal of electropositive element is nothing but metal. Removal of metal is also oxidation reaction. So next, reduction, these are the opposite. So removal of oxygen or removal of electronegative element, that is non-metal, it is called, that means the substance undergo reduction. The next one is if addition of hydrogen atom or addition of electropositive element, that is metal, it is also undergo reduction reactions. Or gaining of electrons is nothing but reduction reaction. The last one is if oxidation state is decreases in a compound, we call it as that substance undergo reduce or reduction. So now we will see one by one, taking one examples. Okay, first we will see the oxidation reactions. First example for the oxidation reactions, that is 2 moles of magnesium is a solid react with oxygen to form magnesium oxide, 2 moles of the magnesium oxide. So here what happened here, oxygen is added to the magnesium, is nothing but, so according to definition, oxygen is added to the metal. So that's why addition of oxygen is nothing but oxidation reaction. So this is a oxidation reaction. And another one is if sulfur, 1 mole of sulfur is reacted with oxygen to form sulfur dioxide. So here is also addition of, in this process addition of oxygen takes place, that's why sulfur undergo oxidized, and this reaction is called oxidation reactions. So these two are example for the oxidation reactions. So how can it define addition of oxygen? From this addition of oxygen we can define these reactions are undergo oxidation reactions. Next, another example, best example for the methane combustion reaction, that is CH4 is reacted with 2 moles of the oxygen to form carbon dioxide plus water molecule will be also, the 2 moles of water will be produced. So here what happened here, simultaneously oxidation and the reduction takes place. Okay, so how to we define carbon here, carbon undergo oxidize, how can it define here, hydrogen will be removing, so hydrogen will be removing is nothing but oxidation reaction. Okay, so here removing of hydrogen and adding of oxygen, so CH4 is converted into CO2, that means removing of hydrogen as well as adding of or addition of oxygen. So removal of hydrogen and addition of oxygen is nothing but oxidation reaction. So from this we can conclude that carbon is oxidized. Carbon is oxidized. Next, if you see the oxygen, what happened here? So here removing of one oxygen or isolate addition of one hydrogen, nothing but addition of hydrogen. Okay, so addition of hydrogen, removing of oxygen, so that reaction we called as a redox reaction. So here reduction, so carbon undergo oxidize and oxygen undergo reduce. So simultaneously oxidation process as well as reduction process both are occurred, that's why this is a example for the redox reactions. And next one is hydrogen sulfide H2S. Hydrogen sulfide, whenever they react with oxygen to form sulfide, 2 moles of the sulfur plus 2 moles of the H2O will be given. 2 moles of the hydrogen sulfide is reacted with oxygen to form a sulfur, as well as the 2 moles of water will be forming. It is also one of the example for the redox reaction. So oxygen undergo reduce, that means reduce, oxygen undergo reduce, and the sulfur undergo oxidation. So removing of hydrogen is called oxidation. Next, addition of hydrogen is called reduction. Simultaneously reduction as well as oxidation both are occurred. That's why it is also example for the redox reactions. Next, magnesium is solid, is reacted with fluorine, is a gas, to form magnesium fluoride. So it is also solid. Next, magnesium is reacted with chlorine gas to form magnesium chloride. Next, another one is magnesium is reacted with sulfur to form magnesium sulfide. So here what happened here? Fluorine, chlorine and sulfur, so which are electronegative elements, highly electronegativity elements. So these elements containing the high electronegativity. So already we know that according to oxidation, addition of electronegative, that means addition of the non-metals, is called oxidation. So here we add the electronegative element, that means non-metals are added to the substance. That's why, so these reactions are called, or these reactions undergo oxidation reactions. So these are the example for addition of non-metals. So these are all non-metals: fluorine, chlorine and sulfur. Next one is with the potassium K4, potassium ferrocyanide, in the presence of hydrogen peroxide, it is converted into potassium ferric cyanide. So it is also example for the oxidation reaction. Oxidation reaction. So how to find out here oxidation? This reaction is undergo oxidation, means how to find it? Here, so before the reaction 4 K plus ions, that means 4 K plus ions are present, but after the reaction only 3 potassium ions are present, and the 1 potassium, that means K plus ions will be lost. Okay, so potassium is a electropositive element. So removal of electropositive element. So here removal of electropositive element is nothing but that reaction takes place as a oxidation. So that's why this is the example for the oxidation reaction. Oxidation reactions. and we will see the reductions. Mercury oxide, 2 moles of mercury oxide, it is a solid. Whenever this substance is heating, what happened here, 2 moles of mercury liquid will be forming, as well as oxygen gas is also will be liberated. So we know that a removal of oxygen is called reduction. So this reaction is example for the reduction reaction. Next, 2 moles of the ferric chloride, it is aqueous solution, reacted with hydrogen gas to form ferrous chloride plus 2 moles of HCl will be given. So it is also one of the example for the redox reactions. Redox means both process will be occur, reduction as well as oxidation. Here plus 3 iron containing the plus 3 oxidation state, and iron containing here plus 2 oxidation state, and the 1 chlorine is removal. So here 1 chlorine will be removal. Chlorine is a electronegative element, so removing of electronegative element is a non-metal. Electronegative element is nothing but that process undergo, or that process takes place as a reduction. So this is a reduction process. So one is reduction automatically, other one is oxidation. For example, you will see the adding or addition of non-metal. So addition of non-metal is a oxidation reaction. So here addition of non-metal undergo oxidation reaction. So simultaneously oxidation as well as reduction takes place. That's why this reaction is example for the redox reaction. Reduction as well as oxidation takes place. And the next example for the reduction reactions. For example, ethylene is taken, C2H4 is reacted with hydrogen gas. So what happened, just hydrogen molecule is addition, CH3, it is converted into CH3. It is a gas. So addition of hydrogen. Addition of hydrogen is nothing but reduction reactions. That's why this reaction is example for the reduction. And the next one is mercurous chloride, HgCl2 is an aqueous solution, is reacted with stannous chloride, that is a SnCl2. It is also aqueous solution to form Hg2Cl2. Next one, SnCl4, stannous chloride and stannic chloride. So here what happened, so SnCl2 is converted into SnCl4, means addition of 2 chlorine atoms. So addition of chlorine is a electronegative, that means non-metal. So addition of non-metal we called as oxidation. That's why stannous chloride undergo oxidation process, and the mercury undergo reduction process. Reduction means here addition of H plus ions, addition of Hg, that means electropositive element, that is a metal. So addition of electropositive is nothing but reduction. So HgCl2 undergo reduction process. So simultaneously oxidation and reduction takes place. That's why this reaction is example for redox reactions. So these are example for some reactions can act as a oxidation process. Some reactions takes place reduction process, and some reactions act as a both reductions as well as oxidation simultaneously. Those reactions are called redox reactions. Redox reactions in terms of electron transfer. For example, we take a sodium metal. So 2 moles of sodium metal is taken and it is reacted with chlorine gas to form 2 moles of sodium chloride. So here the redox reactions we can identify by electron transfers. Sodium is a zero oxidation state because it is a neutral atom, but after the formation of NaCl it is converted into +1 oxidation state. Or sodium is converted into sodium ions, that means sodium is converted into Na plus ions. Na plus means loss of 1 electron. We know that loss of electron according to electron, loss of electron we called as a oxidation. So that's why here how many electrons? Actually 1 electron, but the 2 sodium atoms are there. That's why here loss of 2 electrons. Loss of 2 electrons. Loss of 2 electrons, and this process is called oxidation. So sodium is oxidized. Next one is if the chlorine gaining of 2 electrons. So sodium metal is converted into 2 moles of the Na plus ion, that's why 2 electrons are lost. Now here chlorine gas accepting the 2 electrons, it is converted into 2Cl minus ions. Now here these positive ion and the negative ion will be attractions. So that's why here gaining of 2 electrons, gain of electron is called reduction. So gain of 2 electrons is nothing but reduction. Chlorine undergo reduce. Simultaneously oxidation as well as reduction takes place. That's why this reaction is called redox reactions. But how can we determine? By the using of electron transfer. By the using of electron transfer we can define so which one is undergo oxidation process and which one is undergo reduction process. Generally loss of electron it undergo oxidation, and the gain of electron it undergo reduction. Next, you will see another example, that is sodium metal is reacted with oxygen, undergo sodium oxide, that is Na2O, 2 moles of sodium. So here you will see sodium is converted into Na plus ions, is nothing but loss of electron. So loss of electron, I will write the directly, loss of electron is nothing but oxidation process. How many electrons loss here? 2 electrons. And oxygen undergo O minus 2. So oxygen, neutral atom undergo ion, that means here gain of electrons, that is reduction. So simultaneously oxidation as well as reduction will occur, that's why it is also called redox reaction. And the oxygen undergo reduce, sodium undergo oxidize. Next, another example, take a 2 moles of sodium plus sulfur is taken to form sodium sulfide Na2S. So here oxidation state sulfur is a 0, but it is converted into S minus 2. Sodium is 0, but it is converted into Na plus. So this reaction is also example for the redox reaction, because sodium is converted into Na plus ion. That means loss of electrons is called oxidation, and here sulfur undergo reduce because gain of electrons. Gain of electrons is reduction. So from this reaction is also example for the redox reactions. But we can identify the reduction and oxidation by the using of electron transfer. That's why we can say that heading, that is a redox reactions in terms of electron transfer. So we observe this, we can conclude that all non-metals, that is a chlorine, oxygen and sulfur, so these are always gaining of electrons, and the sodium metal is always losing of electrons. So from this we can define another new terms, which are oxidizing agent, and reducing agent. So oxidizing agent, the substance which undergo reduction. Oxidizing agent, the substance which undergo reduction. And reducing agent, the substance which undergo oxidation, we called as a reducing agent. From these reactions we can conclude that, so which are act as a oxidizing agents? Chlorine, oxygen and sulfur. So these substances can act as a oxidizing agents because these are undergo, sulfur, oxygen and chlorine, these are undergo reduction process. And sodium metal can act as a reducing agent. And we also explained in determination of the equivalent weight in potassium permanganate. Okay, you will see. For example, here you will remember that this is a reducing agent. Reducing agent having always more electrons. That's why donor. Reducing agent can act as a donor. So donor means is a loss of electron. That's why loss of electron is called oxidation. So reducing agent always undergo oxidation process. Best example for this sodium. Next, accepting capacity of oxidizing agent. The substances which is accept the electrons is called oxidizing agent. Oxidizing agent is always undergo gaining of electrons. Is nothing but oxidizing agent always undergo reduction process. Okay, so this is a simple trick. You will remember that always oxidizing agent. You remember that oxidizing agents always containing the more electrons, and the reducing agent always is a empty. That means acceptable capacity is a high, donor capacity is a high. Reducing agent containing the donor capacity and oxidizing agents containing the accepting capacity, which are electrons accepting capacity. So next one is a competitive electron transfer reactions. So generally metals can exhibit the loss of electron tendency. That's why generally not all. So generally metals are act as a reducing agent. So now here not all metals containing the same capacity for losing of electrons. Some metals are donating capacity is high. Some metals are donating capacity is very less. So that's why here the heading is competitive electron transfer reactions. So from this we can conclude that which elements can act as a more tendency for releasing of electrons. Best example for the redox reaction is a zinc metal is react with the copper nitrate solutions. So zinc metal is reacted with the copper nitrate solution containing the ions, that is a copper nitrate, and to form zinc undergo aqueous and the copper undergo solid. So this is the experiment that is given in your book, but finally we can say that so you concentrated on which metals act as a more tendency for losing of electrons. So zinc is converted into zinc plus 2 ions. Plus 2 ions. Zinc is converted into plus 2 ions means is a loss of electrons. Losing of electron or loss of electrons, we know that zinc undergo oxidize. Next, and the copper undergo reduction because here gaining of electrons will be there. That's why we can say that zinc is oxidized and copper plus 2 ions undergo reduce. So simultaneously oxidation as well as reduction will be occur. That's why this is the example for the redox reaction. Next, another example, copper is a solid, react with the 2 moles of silver plus ions to form copper plus 2 ions in aqueous solutions plus 2 moles of silver. It is a solid. So here in this reaction copper undergo oxidation because losing of electrons, and the silver is undergo reduction because gaining of electrons. Silver plus ions is converted into neutral atoms. That is a solid silver. Aqueous is converted into solid. Simultaneously oxidation and reduction takes place. That's why it is also redox reactions. So in this, copper undergo oxidize and silver undergo reduce. And the last one is copper cobalt plus nickel plus 2 ions. These are the aqueous solution, nickel plus 2 ions. The cobalt undergo plus 2 ions, that is a aqueous, plus nickel undergo solid. Nickel, that is a nickel plus 2 ions are converted into nickel atom, that is means metal atoms. So nickel undergo reduction, that is a gaining of electrons. The cobalt is converted into CO plus ions, is nothing but losing of electrons, is called oxidation. Cobalt undergo oxidized, the nickel undergo reduce. So these are the example for the redox reactions. Now we can define which metal? Zinc, and copper and silver. So we can decide which one is more releasing tendency. Electrons are more releasing tendency, which one is? So actually this series will be depend upon the order of the donating capacity of electrons of metals is depending upon it is determined based on the electrochemical series. You will study in second year in electrochemistry chapter. So here you will focus only the order of the metals which are donating tendency is high. So here the order is increasing order, that means zinc will be high capacity. This is a decreasing order of releasing electron tendency. So zinc always losing of electrons is high comparing with copper and silver. So these are determined based on the electrochemical series. Okay, so this is the information about redox reactions.